So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir. Now in today's problem, the topic is that we have to find the pivot index. Okay. So the link will be in the description. You can read in detail. Now I'll give you the quick introduction to this problem. The problem is saying that initially they will be giving us the array. Now if we are standing here, they want to find us the sum of every element present on its left as well as the sum of every element present on its right, excluding this. Okay. Now if you found out the sum on its left, that this will be 11 and this will be 11, right? Sum. So if both are equal, then simply return this index. Okay. So let's consider this left sum to find the sum of every elements present on its left and right sum. Starting from here, let's say this sum will be 1, the left sum will be 1, and for this it will be 3 plus 6 plus 5 plus 6, right? This will be 20. For index 2, the left sum will be 1 plus 7, that will be 8, and for right sum it will be 6 plus 5 plus 6, that will be 17, right? And for index 3 it will be 11 and 11. So you can see that these two are equal, so we will be returning index 3 as our answer. But let's see, for 4 the sum will be 1 plus 7 plus 3 plus 6, that will be 17, and the right sum will be 6 only because only one element present on its right hand side. Now let's come here. Now in the question they have said that since no element are present on its left hand side, so the sum will be 0. Now to calculate the right sum, we have to consider every element, right? Every this element. So it will be 27. Similarly, if we are standing at index 5, we have to calculate the left sum, the sum of all these elements, right? Because they are on the left hand side. So it will be 22 and the right sum will be 0. Why? Because no elements are present on the right hand side. So due to that, the right sum will be 0. Now, if there are multiple pivot index, then we have to return the least minimum. Okay. And if no pivot index is present, we have to return -1. Okay. So this is a quick introduction to this problem. Now let's see that how we can solve this problem. But before that, let me tell you that we have started a series on DSA problem. If you know the fundamentals of DSA, but getting stuck while solving the DSA problems, this series will be helpful for you. If you are preparing for placement and interviews, you can visit to this playlist. The link is in the description box. Okay, thank you. Now let's come back to our problem. As usual, we have to always start with approach 1. This approach will be the brute force. Now if we observe this, what you can do, for every index you can calculate the left sum and right sum, right? If you're standing here, calculate this left sum and right sum. Again, go in index 3, calculate the left sum and then right sum, and so on, right? So this is what I'm trying to say. If you're standing here, calculate the left sum. Okay, so here the index is 2, so start from 1 and go till 0. Now if you want to calculate the right sum, then since we are standing at index 2, start from 3 and go till last index, that is 5, right? So here we will have two for loops for calculating the left sum and right sum, right? So the code will look like this. First of all, we will have the outer for loop in which I will be running from 0 to n. Now we have to also be careful with this condition. If my index is 0, the left sum will be 0, and if my index is n minus 1, the right sum will be 0, right? So if I is equals to 1, at that time my left sum is 0. So this is actually a pseudocode, okay, not an actual code. Else here we have to calculate the left sum. So this can be done by taking the help of another for loop in which j will be running from I minus 1. We have seen this, right? If I'm standing here, I have to start from 1 and it will be going till 0, j minus minus. Now my left sum, since we have to calculate the sum, it will be just, I will be actually taking the help of the shorthand operator, plus equals to a of j, right? Now till this point we have calculated the left sum of a particular index. Now let's see how we can calculate the right sum. Again, if my I is n minus 1, at that time my right sum will be 0, or else for my j will be starting from I plus 1, right? We have seen this case, j is less than n, j plus plus. Now r sum plus equals to a of j. Okay, now if left sum is equals to right sum, then return value of I, right? That's it. So actually here we have to consider that if we didn't found any pivot index, then what you can do, you can initialize at the top answer is equals to -1, and here what you can do, you can assign I to an answer and okay, and then break. If you didn't found any pivot index, then you can simply return this answer. Okay, now if you, now my advice is that if you didn't understand this code, what you can do, okay, if you dry run it, if you dry run it by yourself now, then you will get some idea that how actually the code is running. Okay, now let's see the time complexity of this code. We have actually 3 for loops, 1, 2 and 3, right? But you can see that the inner for loops, these inner for loops are not actually dependent on each other, they're actually independent, right? These 2 for loop. So due to this will be running for n and n, but this outer for loop is actually dependent on this inner for loop, right? So the time complexity will be order of n square and the space will be order of 1, right? Now this is actually a huge time complexity, so let's try to optimize this. Now if you observe, you can see that we are actually calculating the sum using the prefix sum approach, right? I hope you know that what do you mean by prefix sum. If you are standing here, right, so the prefix sum will be the sum of all these 3 elements, right? You can carry forward it, but this is little different. You have to exclude these 3, right? So initially this sum will be 0. If you're standing here, what you can do, you can calculate the sum of this and this, so it will be 1, right? If you're standing here, you can calculate the sum of 7 with 1, that will be 8, and so on, right? So it will be 0, then 0 plus 1 will be 1, 1 plus 7 will be 8, 8 plus 3, that will be 7, 11, 11 plus 6, that will be 17, and 17 plus 5, that will be 22. Okay, so in this way you can actually calculate the left sum, and you can store this in an array. So this will be the array. So the for loop will look like this. For I will be running from 1. Why 1? Because we know that for index 0, the left sum is always going to be 0. It will be going till n I plus plus, right? Now my left sum of I, it will be nothing but sum of I minus 1, right? Left sum of I minus 1 plus a of I minus 1, right? We can see that if we want to get 8, then 1 plus 7, right? So left sum of I minus 1 plus a of I minus 1, right? So using this, you can calculate the left sum of every index. Now similarly, let's try to find the right sum of every index. Now what you can do, you can start from the last index, right? The right sum of the last index will be 0. So if you come here, it will be 6 plus 0, that will be 6, right? If you are standing here, the right sum will be 6 plus 5, that will be 11. If you are standing here, the right sum will be 11 plus 6, that will be 17. If you are standing here, 17 plus 3, that will be 20. And for index 0, it will be 27. 20 plus 7. So the for loop for right sum will look like this. For I equals to n minus 2, okay? N minus 2, not n minus 1. I will be greater than equals to 0. I plus plus. Right sum of I will be right sum of I plus 1 plus a of I plus 1. Again, if you didn't understand, please try it by yourself. Now using this, we have calculated the right sum and left sum. Now what you have to do, you have to simply take another for loop and compare these two values in every iteration. If you found the left sum and right sum are equal, then simply return that index, right? But you have to take care that if the index, the pivot index is not there, then you have to return -1. So how you can solve that? You will have answer as equals to -1. Now for I will be running from 0 to n if my left sum of I is equals to right sum of I, then update your answer and then break it, because they are telling us to send to return the least minimum index. So simply break it and then return your answer. So if you didn't found any pivot index, you will not enter in this if case, right? You will simply return answer, which is actually -1, right? So in this way we can solve this problem. So if you see the time complexity of this problem, there are actually 3 for loops here also, but all are actually not dependent on each other, right? This is running for n time, this is also running for n time, and this is also running for n time. So it will be 3n, it will be order of n, okay, time complexity. But we can see that we have taken the help of extra space, the left sum and right sum, which is 2n. So again, order of n. So with this approach, we have actually optimized the time complexity, but we have increased the space complexity, which is order of n, right? So there is one more approach that we can do this without taking any extra space. Okay, so let's see that. Since we want to find the left sum, what you can do while traversing in an array, you can calculate this sum on the go. What I'm trying to say, see, if you're standing here, my left sum will be 0. If you're going in this, what you can do, you can take this one and this one into consideration. So the sum is 1. If you're going here, take this 1 and 7, that will be 8. If you're going here, 7 and 3, that will be 11. If you're going here, 11 and 6, that will be 17. And if you are going here, 17 plus 5, it is actually 22. So you might think that we are actually doing the above approach only, but no, that this is not the case. We are actually storing this in left sum variable. I'll show you how, but give me some time. Now left sum is sorted. Now let's try to calculate the right sum. Now if you calculate till this point, if you calculate the sum of every element, it is turning out to be 28. So the sum is 28. Okay, now if I'm standing here, if I'm standing at the 0th index, what I want, my right sum, that is the sum of every element, right? But we know that the sum of every element is 28. So what if I exclude this one? What if I exclude this one? Then I'll be getting the sum of these elements, right? So 28 minus 1, 28 minus 1 will be 27, right? So for this point, I got my right sum. Let's see whether we are getting if we are standing at index 1. Now for index 1, the right sum is nothing but the summation of 3, 6, 5 and 6, right? Now what is 27? 27 is nothing but sum of every element starting from 0 to 5 minus a of 0, right? This is actually 27, right? If I subtract 7 from 27, I'll be getting 20. What does that mean? We know that 27 is nothing but we are subtracting 1 from 28, 1 from 28, right? Now if we subtract 7 from 27, that will be 20, all right? So this is nothing but the summation of these elements, right? So this will be 20. Similarly, if I'm standing at index 2, I'm subtracting 3 from 20, so it will be 17. If I'm standing here, I'm subtracting 6 from 17, that will be 11, and so on. Okay, now let's try to see the pseudocode, then you will get the clarity. For I will be running from 0 to n to calculate this sum plus equals to a of I. Now my left sum will be 0 and my right sum will be actually 28. Sum minus a of 0. My left sum is 0 and my right sum is 28 minus a of 0, that will be 27. Okay, now here I'm going to see whether left sum is equals to right sum or not. If it is, then I'll simply return 0. If my left sum is equals to right sum, just bear with me. Okay, I'll explain this approach in detail. Return 0. Now using the for loop in which I will be running from 1 and it will be going till n, my left sum is nothing but I'm actually adding 1 to my left sum. Okay, so a of I minus 1. Okay, so if I'm standing here, left sum is 0 plus 1, that will be 1, and here I want to calculate the right sum. So right sum will be, I want to subtract 7 from 27. So right sum minus plus equals to a of I. So this will be 20, and that's it. So here if my left sum is equals to right sum, if my left sum is equals to right sum, return I, right? So here you can see that we didn't take any extra space, right? We have just solved this problem using two for loops which are not dependent on each other. So time complexity will be order of n and space complexity will be order of 1. But let's try run this so that you will get the clarity. Now my value of I is 2. Left sum will be 1 plus 7, that will be 8, and my right sum will be, I have to subtract 3 from 20, that will be 17, right? Now we are going to check, is 8 equals to 17? No. Then go forward. My value of I is 3. Here I am going to add 6, sorry, here I am going to add 3 with 8, so it will be 11. Now to calculate the right sum, subtract 6 from 17, that will be 11, right? So these two are equal, so return 3. So in this way you are going to solve this problem using approach 3. Now let's try to code this problem. So don't worry, I'll be putting the problem link in the description box so you can practice. So sum will be initially 0. Let's calculate the sum. So I'll be using the enhanced for loop, int nums sum plus equals to num, right? Now int left sum will be 0, int right sum will be sum minus nums of 0, right? Now here we are going to check whether my left sum and my right sum are equal or not. If left sum is equals to right sum, if it is, then simply return 0, because we found our pivot index at 0 only. Now but if this is not the case, then int I will be running from 1 and it will be going till nums of length. Now to calculate the left sum, it will be left sum plus a of nums of I minus 1. To calculate the right sum, it will be r sum minus nums of I. Now here we are going to check if my left sum is equals to right sum or not. If it is, then I'll be updating my answer and break. Now after that, simply return answer. So let's initialize the answer variable as -1. Okay, I hope you got this code. So let's run this code. Okay, so you can see that this code has passed 3 test cases. Let's submit it. Okay, so you can see that this code has passed all the test cases, right? So in this way you can solve this problem. So it's actually the easy one, but give this a try and try to dry run this code by yourself if you didn't understand it well. Thanks for watching this video till this point, and don't forget to like, share and subscribe to my channel. Okay, thanks for watching.